Alright everybody, this is unit 2.11, Momentum, part 1. That's right, you heard me right, it's part 1. You see, it's so big and it's so hard to actually comprehend what they're trying to say. They split it into 2 parts. Oh my god! Alright, what is momentum? Momentum is mass times velocity. Just ignore that. It is represented in kg per meters a second. It is also a vector, meaning it has a positive or negative sign. An example is negative 6 kg per meter a second, or positive 100 kg per meter a second, and etc. etc. Ergo, therefore, a heavy object traveling at high velocity will result in high momentum, like a sumo fighter falling from the sky. However, light objects traveling at low speed will result in low momentum, like a punch from Hazin. You see, the sumo, he's very heavy, right? Very heavy. And falling from the sky, oh man, you fall really fast. So, falling fast plus heavy equals momentum high. And like Hazin, his fist, is basically just bones. So it's about negative 2 grams, and so times its velocity, which is 0, and so you get practically 0 momentum, and you won't get hurt by it. The link. What you might not realize is that there's a link between momentum and Newton's second law. How? As you know, the law is F equals ma. But it could also be used like this. F equals change of momentum over time. Force equals to mass times acceleration. Acceleration is a change of velocity over time, and momentum is a mass times velocity. So, if you get change of momentum over time, you will get the force. It's a bit complicated, and it's kind of a roundabout way of finding the force, but whatever. Sometimes you do need to use this method. Impulse. No, we're not talking about Impulse the YouTuber, or Impulse when you see a shoe and you want to buy it. It's impulse. It is resultant force times time equals to change in momentum. This is a rearrangement of the previous equation, but it comes in handy. Change in momentum is called impulse. Change in momentum is called impulse. Remember that. It's really important. Alright, practice. Let's say there's a car traveling at a speed of 90 meters a second, and its mass is 50 kg. Its speed increases to 100 meters a second in 10 seconds. What is the car's resultant force? We use momentum. We use momentum equals to mass times velocity to get the initial and final velocity. Then we use resultant force equals to change in momentum over time. So the momentum is 50 times 90, and the final momentum is 50 times 100. So the force is 5,000 minus 45,000 divided by 10. So 5,000 minus 45,000 is 500, and 500 divided by 10 is 50. So the force is 50 newtons. Good job. That was pretty hard, but you did it. Here's an easy example. If a truck with a mass of 300 kg, yes, 300 kg, is traveling at a velocity of 100 meters a second, then what is the momentum of the truck? Yes, I know it's easy, and I should have put this before the previous question, but anyways. The formula for momentum is mass times velocity. The mass of the truck is 300 kg, and the velocity is 100 meters a second. So it is momentum equals to 300 kg times 100 meters a second. So the momentum is 30,000 kg meters a second. That's a lot of momentum. Alright, anyways, here's a picture of a truck, and bye. That's about it.